Good morning, one and all dear students. I welcome you all to the virtual lecture in the subject digital signal processing. So today we are going to deal the fifth unit of the subject, that is multirate signal processing. So I hope you can see the board clearly. Unit 5. So this unit specifically have two parts. In the first part, we will be discussing with the multirate signal processing. So this is part A, and in the part B, so we will have the discussion on finite word length registers, finite word length effects. So right now we'll be discussing the concepts of multirate signal processing. Then in the next step, I'll share the content with respect to finite word length effects also. So in multirate signal processing, we will be dealing with the concepts of decimation. Then we'll be dealing with interpolation. And we'll be dealing with sampling rate conversion. Sampling rate conversion by rational factor. So these are the main topics that we will be dealing with the multirate signal processing. And coming for the finite word length effects, we'll be dealing with quantization, the different types of errors like quantization error, then round off, truncation, overflow, limit cycles, and limit cycles. So that's all. That were the deadband effects. So these are the topics that we'll be dealing with the finite word length effects. So coming for the multirate signal processing. So first we'll see the introduction about the topic. So what exactly multirate signal processing is. Then how interpolation and decimation processes were performed, and what is sampling rate conversion with respect to rational factor. So these are the topics that we'll be observing in this particular unit. So let me share the PowerPoint presentation with you so that it will be easy for you to even understand the concepts very clearly. So when we say about multirate signal processing, the first and foremost idea that we will get into our mind is what exactly is multirate signal processing. So that means you know, when you need to process a signal, we are dividing that, or we are converting that signal into its digital equivalent for simplicity and ease of processing. So when we are doing that case, so it is not easy, or it is not possible to transmit the signal or process the signal which has a single sampling rate. For example, you consider your CD. So when you see a CD, the data that you write on the CD will be at 44.1 kilohertz speed. So it will be specified even on the CD also. If you observe carefully, you will find 44.1 kilohertz. So, but practically speaking, so when you play it on using a CD player or your system, so the sampling rate will be different. So then you should have a conversion technique so that the data in the CD can be framed and can be displayed or can be played. If it is an audio file, if it will be played on the system or using a CD player. So similarly, there are n number of examples you can state. So you can see subband coding techniques, you can see filter band techniques. So like that wavelets processing. So all this will be part of multirate signal processing. So let me show you the PPT. So here you can see. So when I'm saying about the multirate signal processing, right. So as I've told you, 44.1 kilohertz is the data at which you write the CD. But when you have to play it in a CD player or a video player, you have to go with 48 kilohertz. So where you require the sampling rate conversion in order to play the video, so or the audio. Similarly, we say 24 frames per second. So when we see about the films, so the frames per second will be recorded at 24 frames per second. But if you have to display it on a TV screen or your cinema theater screens, they will be of different sampling rates. So they do require 30 frames per second or 70 frames per second. So like this, so different types of sampling rates are required in order to display the content that was present in the reel. So we do require the concept of multirate signal processing, and hence it is introduced in order to sample your signal at different sampling rates, so that you can have the transmission as well as the reception at a proper communication. So multirate signal processing often uses sampling rate conversion to convert from one sampling frequency into another sampling frequency. That is what multirate signal processing is. So it converts the signal from one sampling rate to another sampling rate, and it is called sampling rate conversion. So we have two methods of this sampling rate conversion. The first method, the data that you have, which is the digital data, so it has to be converted into the analog data using DSP, and then you need to give your new sampling frequency, so with which you sample the signal and then convert it back into the digital. So this is one method of converting the sampling rate. So try to understand carefully. So initially you have the digital data. So this digital data is converted into analog data. So this analog data is sampled with a different sampling frequency compared to the previous case. That means, so where you have this digital data at the initial, you would have sampled with some sampling frequency. Now this second type of, the second time that you are sampling will be sampled with a different sampling frequency. So you have converted into the digital back again. So let me give you an example. So initially you have sampled your signal that was present in your CD with 44.1 kilohertz, let us suppose. So that data you are converting into analog format. The digital format is converted into analog format using DSP. And this analog signal, whatever you have obtained, is again converted into digital with some other frequency, let us say 48 kilohertz. So that is the difference, so that you can play it on the CD player. So that is how we introduce this sampling rate conversion in the first method. So, but this has some disadvantages, like you have to do 2 times the process of DAC and ADC, where you have the noise or the distortions being introduced because of this A to D and D to A conversions. So this is the limitation with the first method. So when we come for the second method, so where we have the digital domain access directly. So as we have seen for the IIR and FIR filters, even you cannot design a IIR filter directly in the digital domain. Rather, you have to consider the analog and then you have to convert it into digital. So similarly here, the first method, so you have to convert into analog and then convert again into digital with some other sampling frequency. Now the second method is something like your FIR filters, where you have the design concepts directly in the digital domain. So here also we have the design concepts directly in the digital domain. So where we have the concept of decimation and interpolation. Now what exactly this decimation and interpolation are? So decimation refers to downsampling and interpolation refers to upsampling, right? So we'll continue the video in the next session.